In numerous cancers, the epidermal growth factor receptor, or EGFR, is often inappropriately activated, leading to uncontrolled cell growth, as for example here in the colon and in the head and neck. Erbitux, a member of the class of drugs called monoclonal antibodies, has been developed specifically to block EGFR, thereby blocking tumor growth and inducing tumor regression. The following film will exhibit the 5 mechanisms of action of Erbitux. Proliferation and survival of cancer cells involve the binding of epidermal growth factors, or EGFs, on their receptors. This triggers intracellular cascades of the EGFR signaling. Leading to the activation of genes which drive the cell cycle and mitosis. Erbitux is specifically designed to bind to the EGFR and inhibit this signaling. Thus inducing cell cycle arrest of the cancer cells and stopping their proliferation. Moreover, Erbitux suppresses the survival signals required by cancer cells. When cancer cells go through epidermal mesenchymal transition, or EMT, their expression of adhesion molecules is modified, thereby allowing migration. Again, EGFR plays a key role in this process. By precipitating these invaders into a retro-EMT, Erbitux hinders their mobility and invasiveness, thus preventing the dissemination of tumor metastases. In addition, and once more due to the docking of Erbitux at the EGFR, the cell does not receive the necessary survival signal and goes into apoptosis. Like all cells, tumor cells require oxygen and nutrients, yet due to their malignant growth, new blood vessels are nearly continuously required. By producing various pro-angiogenic factors, they are able to trigger and drive the sprouting of new blood vessels from nearby existing ones, a process also depending on EGFR signaling. As opposed to conventional VEGF inhibitors, Erbitux blocks angiogenesis at the source, here at the tumor cells. Moreover, Erbitux does not only block the expression of VEGF, but also of other vascular growth factors, in example IL-8. In the bloodstream, Erbitux can bind on natural killer cells, or NK cells. In contrast to IgG2 antibodies, the IgG1 antibody Erbitux is able to induce antibody-dependent cellular cytotoxicity, or ADCC. By its EGFR-specific character, Erbitux designates the cancer cells as targets for this immune reaction. Accordingly, the NK cells recognize EGFR-expressing tumor cells, transmitting to them the fatal signal which activates their own cell death program, apoptosis. As classical anti-cancer treatments such as cytotoxic agents are used, and reused, some cancer cells become resistant. Thus, fewer and fewer cells die upon the successive cycles of therapy. However, one of the multiple processes causing this multi-drug resistance is DNA repair, a mechanism itself depending on EGFR signaling. Again, by blocking the EGFR, Erbitux inhibits this DNA repair. Erbitux works synergistically with chemotherapy in order to drive more tumor cells into apoptosis. But it's the synergy and directness of Erbitux's all 5 mechanisms of action that make the difference. Accordingly, the 5 mechanisms of action of Erbitux act united and directly against cancer cells, thus providing a very efficient means of fighting cancer.